Dear friends, how are you all? And how is your preparation going on for IIT JEM Mathematics examination for 2022 session? So for this and moving forward, we are continuing our lecture 3, which is on sequence and series. So first of all, we will see some general result about sequence and series, some properties of that which may look trivial, but we have to prove right. So let's discuss. So first one is this, that every convergent sequence is going to be bounded, right? We have earlier defined what is mean by convergent sequence. Once we know that, I will recall the definition. The definition is that for any convergent sequence xn, say xn converges to some L, then you know that mod of xn minus L is less than epsilon for all n greater than equal to n naught, and this n naught is going to be depend on epsilon, right? So let us consider a sequence xn, which we say here it is xn, and we know that from the given hypothesis that our convergent sequence is given to us, then xn is our convergent sequence which converging to some point, say x is any number, right? Then for any given epsilon, in this case we are taking our epsilon to be 1, right? So for epsilon equal 1, can you get some n naught, which by definition you know, right? By the definition you can get some n naught, and this n naught coming from natural number, as you know, right? So what we get is this one, xn minus x to the power mod is less than 1 for all n greater than equal to n naught. So what happens is that for all n greater than equal to n naught, we have a condition, right? That is mod of xn is less than equal to mod of xn my x minus xn plus mod of x, this one, which is less than 1 plus mod x. So do you know how this condition comes? The first part comes from the triangle inequality, as you are all familiar with, and second part comes from the thing that your mod x minus xn is less than 1, right? In that case your epsilon is 1, right? Is it fine for you? And then you just see that you can consider the set C is the set with this one. Have a look at this. So what you recall from it, that C is consisting of the maximum of the elements like mod x1, mod x2, and up to mod xn naught minus 1, and they are taking it with 1 plus mod x. You know that for xn, all the xn's are going to be bounded by 1 plus mod x, right? For all n greater than equal to n naught, right? But you want the upper bound for all the terms which are less than n naught, right? That is also we want. So for that we need some terminology that gives a uniform upper bound for all the elements of xn, right? So for that, what you can see is that you can take the maximum of 1 plus mod x, and with the maximum of mod x1, mod x2 up to mod x and not minus 1, because we don't know whether 1 plus mod x is lesser than uh, mod x1, mod x2. Is it greater than? We don't know, because for n greater than equal to n naught, we know that this is going to be a greater than mod xn, right? So in that case we need to take the maximum of the preceding terms also, right? So it ultimately say that for every xn you are able to get, for every xn you are able to get some mod less than equal to m, right? So in that case it is fine, right? So C is going to an upper bound for all xn. In fact, it is the uniform upper bound, right? So you say that your convergent sequence is bounded in that case. Is it fine for you? I think it is fine. So this is one beautiful property of the convergent sequences you should know about. Okay. So moving forward, we will see that there are some usual properties that you know about the sequences. Right? What are the usual properties? Let's see. If xn goes to x, means xn converges to x, yn converges to y, and you take any alpha in your real line, then what you see? First one, xn plus yn converges to x plus y, right? Means limit of xn plus yn as n goes to infinity is going to be x plus y. Second property says that if you have alpha xn, then it is going to alpha x, and alpha can be any real number, right? In that case, third property says that if you take the product of term by term product of the sequences, then you will get this one, xy, means x and y converges to xy. And the last property says that 1 by xn converges to 1 by x, right? Why it is true? Why we are considering 1 by xn? because you know that for x non-zero, our xn coming out to be non-zero for all n greater than equal to some capital N, right? Is it fine for you? And you see that 1 by xn is defined in the case, because if xn is 0, then you can't define your 1 by xn, right? So for all n greater than equal to n naught, after finitely many terms, you can define your 1 by xn, and hence you can prove that 1 by xn converges to 1 by x. So how will you prove that? So these are four properties. You need a proof of that. Is it very easy or is it very trivial? Right, it is very easy, I say. So you can work on for some of sequences. So you just try to work with the definition and merge them both with the help of triangle inequality. For B part, also use Archimedean property. You can use that. Can you use that in the B part or no? If not, then you can easily prove that. You can change the scale of epsilon. You can do that. And for C part, it's very easy. You can again merge the properties and scale your epsilon. So right, for D part also you can work the same way as C part, just making substitutions. That's easier, right? So these are some basic properties. You should know them at all, at least once. You should know them, right? So moving forward, we see that if we take the set of our convergent sequences of real numbers, right, and the beauty of that is that it forms a real vector space. You know what is vector space? You know, vector space is going to be an abelian group over some field f, right? V plus and f plus dot is a field. Then you can always define a map from f cross v to v, which sends every element like alpha x, alpha comma x, topple to alpha x. You know that this is the definition of vector space, which satisfies some other four properties. So you need to verify them, right? So for first one, you see that if you take the set of convergent sequences, then you know that is it closed under scalar addition? Is it closed under addition? Right? If you take any two sequences which are convergent, then their sum is also going to be convergent. We know that from the earlier properties. And moreover, if you consider alpha is a field member, and if you consider alpha xn is equal to alpha xn, then it is going to be same as this one, right? In that case, scalar multiplication plays a beautiful role. Okay, so that's fine. And other vector space properties you can easily verify. What are the other ones? If you say alpha xn plus yn, then it is just same as alpha xn plus alpha yn. Xn plus yn alpha is same as xn alpha plus yn alpha. You can verify that. I don't think so that will be tougher. Right, fine. Okay, so we have a look at this one. This is very important. The map from C to R. You can always construct a map from set of convergent sequences to real numbers. You can send every sequence to its limit, right? Because your sequence is convergent, you can send it to limit. This is a function which sends every sequence to its limit. Then you see that it is going to be a linear transformation, right? Why is that? For linear transformation, you should know that phi x plus y is same as phi x plus phi y, and phi cx is same as c phi x. Here c is in field R, field f, where field f is R here. Okay, so you see that phi xn plus yn is same as the phi xn plus phi yn, and this part phi lambda xn is same as lambda phi xn. So these properties are trivially satisfied. Is it true? Right? So this is going to be a linear transformation. Anyways, this is very easier, but you should remember this, that the set of convergent sequences of real numbers is going to form a real vector space under the operations that I have defined. And second one is that if you have a map phi from C to R, then you say that you can always construct a map from set of convergent sequences to real numbers. If someone asks you, then you just give this map. So this sends every convergent sequence to its limit. Right? Is it fine? So this is very beautiful, right? In that case. Okay. So moving forward, we see that if we consider some questions related to it, then you see that let xn is this one, and you have to show that xn is convergent, this one, second one, third one. So these are very important questions, I think you can do them. So I hope that you can do them. And if you feel any questions, if you feel any problem in them, then you can always mail me, or you can always comment on the chat box. I will always reply. So that's easier. They are based on the properties that we have discussed today. Okay. So thank you very much for today. Hope you will enjoy it. Hope you have enjoyed it. And don't forget to subscribe this channel, IIT in Talks. I will be updating more lectures, right? So be ready for your IIT Jam 2022 examination. I will be discussing some more few topics for more important topics. Stay updated. Thank you very much.